Writing reliable code means making testing part of your development process, and Hammer is no exception. Hammer provides some test macros that work with the glib testing library. They're not installed in /user/local/include/hammer by default, but if you want to use the test macros we've developed, you can include the source/testsuite.h header from the Hammer source directory in your project and link your tests against libglib. That's what we're going to do here. First, we need to make a working directory. And then copy in the test suite header. If you'd rather use another unit testing framework, you can still use the same test vectors we'll use in this video. This testsuite.h file has the macros we wrote to use with glib. Conveniently, RFC 4648 provides us with some simple test vectors for base 64 so we can write a decoder and test it. An empty input encodes to an empty output. A single 8-bit character encodes to a 4-character output block, including 2 characters of padding. 2 characters encode to a 4-character output block, including 1 character of padding. 3 characters encode to a 4-character output block with no padding, and so on and so forth as the input size cycles modulo 3. Our unit tests will of course work the other way around, decoding the encoded strings to produce the original input. But first, we're going to verify that the parser we're going to write parses only strings in the base 64 language and rejects strings that aren't in the language. First, we need to include the Hammer include file and the test suite include. Then we'll stub out the test registry. And a main function to call it. Since we're writing the tests first, and we're going to build the parser here anyway, we'll stub it out as well. We'll declare it at global scope because we're going to give it a singleton initialization pattern. We initialize the parser to h0p, which is a parser that always fails, because null is an invalid parser, and there's a distinction between a parser that doesn't work and a parser that tells you every string is invalid. h0p always runs but never succeeds. A broken parser doesn't even run and will probably segfault. So now we initialize the singleton parser, and we have everything we need in place to start laying tests down. Just to get this up and running quickly, we'll start by banging all the cases into one test, because we know that with base 64 implemented as the nothing parser, they'll all fail anyway. This gcheckParseOK macro just checks whether its first argument, the base 64 parser, successfully parses the input provided in the test case, here the empty string of length 0. pbmin is actually the backend selection to run with this case. That defaults to the packrat parser. This may change in future versions. So now we'll add the rest of the RFC 4648 vectors. Of course, we also want to make sure that an attempt to parse an invalid base64 string will fail appropriately. And because we reason through the subtleties of what makes a base64 string valid or invalid, we can use those to come up with good test cases really easily. We know that there are only 64 characters in the base64 alphabet, and if an input contains any other character, that's invalid, so we'll write a test case for that. And then there are the two subsets we identified of final content characters when there's padding. If there are two padding characters, the last content character can only be a capital A, capital Q, lowercase g, or lowercase w. So let's write a test that uses something else. And similarly, we'll write a test for the one padding character case where the last content character isn't one of the 16 valid choices. We also know that the size of the base64 string in bytes has to be divisible by 4, so let's make sure it fails when that's not the case. And finally, we'll put in some bad inputs involving padding, starting with the one we crashed the Samba web admin tool with. Okay, so that should be enough cases for now. Let's add this test to the test suite. That slash at the front of the path is required. Then save it and compile it. The call to package config tells the compiler where to find the glib library to link against. Then run it. And of course, all the tests fail because nothing is currently being parsed. We declared that explicitly when we said that the base64 parser is temporarily the nothing parser. In the next video, we'll put a real parser in place. Between now and then, it'll be your job to refactor those test cases. Split each one out into its own function, and then register those functions in register base64 tests with their own path names, and watch how the test runner output changes when you recompile and run the tests again. You'll need to pass a -k argument to the test base64 binary to get it to keep running past the first failed test. That's a glib thing. So use the glib documentation if you need some help understanding how gtest init, gtest addfunc, and gtest run work, or if you want to try out some of glib's other testing features. See you next time.